Hello class, welcome to section 6.5. Today we're going to go ahead and find the average value of a function. We're going to come back to this picture in just a little bit, so let's just go ahead and remind ourselves, how do we calculate average? Okay, if you wanted to figure out your average scores on your 4 common exams, you would add up all the scores and divide by the number of exams you've had is 4. So here's how we can depict the average of our y values. So you do y1 plus y2 all the way up to the number of y values, and then you divide by that number of numbers. That's how you find average or mean. Okay, so what we're going to do is we are going to look at some curves today, or some functions, and we want to figure out, well, on average, what was happening? Okay, so what if we wanted to find the average temperature for the day? Okay, if I have my graph here, what I would want to do is figure out, well, here's some highs and here's my low, but on average, it looks like my temp was, I guess this is in Celsius, like 4 degrees Celsius throughout the entire day. So how would we figure out the average from my curve or from a function? Okay, so the equation comes, is right here. I'm going to explain to you where it comes from. But F average, okay, this line right here, this is your average. If I was going to say the function, how it was behaving over a period of time, this is your average. Okay, so this is F av or F average, like AVG. Okay, it's essentially the height of a rectangle. Do you guys see how if you could take this and put it in this space, it would kind of make a rectangle? So what I would say to you is, how do you guys find the area of a rectangle? The area is base times height. Well, what is the length of my base here? It would be B minus A. So I would take B minus A times the height of my box, which is F average. And that would be equal to the area underneath my curve, okay, which is the integration. We know the area, which is A to B, f of x, dx. So how am I taking this idea and going from here to here? We're really dividing by b minus a on both sides. So we just write it out in front, 1 minus b over a. So that's how we would figure out the average. Okay. So this is the equation we're going to do. So basically we're doing integration, and in front we're going to write 1 over b minus a, our intervals. But that finds, on average, how is this function behaving. So example 1, find the average value, so be careful, average value of the function f of x on the interval from -1 to 2. So the average is equal to 1 over b minus a, and then our integral from a to b, f of x dx. Okay, so we would have 1 over, this is a, this is b, 2 minus -1, then our integral from -1 to 2, and then our function, 1 plus x squared dx. So let's go ahead and calculate this. 1 over 3, and then I would take the antiderivative of this function, so I would have x plus 1/3 x cubed from -1 to 2. And then I would calculate this out. So I'd plug in 2. I'd have really 2 minus a -1. Then it'd be plus 1/3, and then it would be 2 to the third is 8 minus -1 cubed, which will give me -1. So here I'll have 1/3. What's this going to give me? This is going to be 3 plus 1/3 times 9. So 1/3 times 9 is really the number 3. 3 plus 3 is 6. 6 times 1/3 is 2. Okay. So on average, okay, for this function, it would have a line y equals 2. Okay. Go ahead, try this one on your own. Pause the video and give it a try, but find the average value. Hopefully you paused it, tried it, and I'm going to write it down. So we got the average of our function is 1 over b minus a, then the integral from a to b, f of x dx. The only thing we're really adding on for average value is the 1 over b minus a. So we have 1 over 5 minus a -2, -2 to 5 of our function 8x cubed dx. So this really gives us 1 over 7. Then I'm going to take the antiderivative. I have x to the 4th going up a power, and then I would have 8 divided by 4, which gives me 2, from -2 to 5. So then I will have 1/7. Then I have 2 times 5 to the 4th minus a -2 to the 4th. using my calculator, let's see. This is this part right here, sorry, will give me 609. Then I would take 609 times 2. Okay, so I would have 2 times 609 divided by 7, which gives me my final answer of 174. That would be the average value on the function for that interval. Okay. Example 3, we have the velocity of a vehicle is shown. Estimate the average velocity during the first 10 seconds. So basically we want to find where is the average velocity, where's the line for the first 10 seconds. This one says estimate. Okay. The reason it says that is because I don't know the actual function value, or sorry, the function for this curve. So I'm going to have to either use left or right hand Riemann sums. And I'm going to just tell you I want us to use for this one right hand Riemann sums with 5 subintervals. Okay, that's where we're going to find our integral. So let's just remind ourselves. We would have the average value is 1 over b minus a, and then it's the integral from a to b of f of x dx. And then when I plug it in, my b and my a, the interval I'm talking about, the first 10 seconds, is really from 0 to 10. So my average velocity, so I'm going to say v average, my average velocity will be 1 over 10 minus 0 from 0 to 10 of f of x dx. Okay. In order to find this part, it's an estimate. I'm going to use my Riemann sums with 5 subintervals. So we have to remind ourselves how to find r sub 5. And then when we do that, we'll just go ahead and take our final answer times 1/10. So maybe a little work off to the side. I'm going to find r sub 5. My intervals are from 0 to 10. So remember we would do b minus a for this. So it's 10 minus 0 divided by how many subintervals it is. And I would want divided by 5 is how many subintervals. And then 10 divided by 5 is 2. So that means each rectangle will be a width of 2. And I'm going to do right Riemann sums. So r sub 5 in this case, the height of all my rectangles is 2, will be 2. And then I'm going to say f of, my first value would be 2, plus f of 4, plus f of 6, plus f of 8, plus lastly f of 10. It's getting crowded, sorry. Now let's go ahead and find those values. So f of 2, take it up to the curve. It's kind of hard for me to draw accurately. I feel like when I did it on my paper, I got that this was around maybe 8 or 8.5. Okay, so this would be, let's go with 8. F of 4 looks like 9.5 to me. And it's an estimate. I might be off a little bit if you're getting something different. That's okay. Let's go ahead. F of 6. It's looking like 10. If I go over 10. F of 8. Looks like 9.5, same as the other one. 9.5. And then lastly, F of 10. And head on over. That one maybe not as high. Let's go with 9. This one's 10. 9. Okay. Good. It's kind of hard to see. So this one's equal to 9. So when we're still finding my integral from 0 to 10 using an estimate of f of x dx. So what we do is add up all these numbers. And I don't have this, so I'm going to quickly do that. We got 8 plus 9.5 plus 10. 9.5 plus 9. And I got 46. So I would have 2 times 46, which is equal to 92. So my average, my velocity average over this entire function would be 1/10 of r sub 5, plugging this in, is 92, which gives me 9.2 meters per second. So on average, for those 10 seconds, my average velocity was 9.2 meters per second. Okay. Example 4, using the same picture, at what time was the instantaneous velocity equal to the average velocity? Well, we just said our average velocity was 9.2 meters per second. And this graph is showing our instantaneous velocity at 0.1 second. It's like 1. At 0.2, it's increasing very quickly. So we're going to go over here. This axis is showing our instantaneous. So what I want to know is, when are they equal? Well, I'm just going to mark on here 9.2. Do my very best to draw a straight line. You guys can do it a little nicer on your iPad. Okay. And then I would just go down and find the time. So it's wherever it intersects the graph. When I did on mine, I got 3. Oh, that's really crooked. Going straight down, and 9. So what my answer would be is that at time t equals 3 seconds and at time t equals 9 seconds, my instantaneous and my average velocity are equal to each other. Okay. That is the end of the notes today. You have problems 1 through 4, 15 through 16 from the book. If you have any questions, feel free to message me. Otherwise, I'll see you later and have a great day.